Hello there, Year 8. This is our new topic, first lessons. This is very, very important. Our new topic is chemistry on Earth. The first lesson is revision to make sure we've got all the language, all the understanding from earlier in the year that we need to be able to access the later lessons. Although you're at home, there will be some activities that we can do at home which will actually give us some practical work to do with this topic. So it's been quite exciting. Now you are going to need a place to collect vocabulary as we're going along. You are going to need a periodic table. Hopefully you've still got your planners with you. If you haven't, I will put a copy of the periodic table on Teams and also on Go for Schools, and you can download that and use it when you need to. Now you've got 4 images here. You need to describe those images. Each image only needs one word, specific label. Remember, this is your do now task, so you are going to need to pause the video while you do it. So here are your answers going from left to right. The first one has a set of identical red coloured individual atoms. So this is an element where you've got the individual atoms clearly visible. The next one has also got only dots of one colour, they're blue, but this time the 2 atoms are joined, and these 2 identical atoms joined together to make a molecule. An example of this would be the gas oxygen, which is a molecule O2. The 2 showing us there's 2 atoms joined to make a molecule. Third one along, it's also a molecule, but this time you've got 2 different colours. You've got 3 green atoms and 1 blue atom. As they're different atoms from different elements shown by the different colours, it is called a compound. So a compound has elements that are different from each other, 2 or more. So a compound, like a compound word, has 2 different words joined together. For example, the American word sidewalk, which means pavement. Side of the road, walk is what you do to it. That's compound. And the last one is a mixture. It's a mixture because it's got all sorts of things together. It's got some atom, it's got an element, it's got a molecule, it's got a compound. Each of those are existing there, but they are not joined together. They are just in the same space. A little bit like if you put sand and sugar together in a container. They are in the same container, but the sand and the sugar are not joined and can be separated. That's what a mixture is. Now, this has got quite a lot of objectives. I told you it's a very important lesson. You are going to need to practice as you go along. You are going to need to make good quality notes as you go along, because this is the foundations for everything else we're doing. We need to get this right to have everything else work nicely. Think about when you're playing Jenga. If you try to take one of the blocks out at the bottom, the whole tower will fall, and that's because the blocks at the bottom are the foundations. So you've got 6 objectives here: revising how many protons, neutrons and electrons are in an atom, spotting periods and groups, that's on the periodic table, which, as I've said, I will supply for you if you haven't already got one with you. Writing word equations, this is a key objective for Year 8. Knowing how to name compounds that have got 2 elements in, knowing how electrons are involved in reactions, and knowing 3 types of chemical bonding. So, first one, you should already know this, but if you are not sure, you might want to copy this into your book, either in my words or your own words. So an atom is the smallest piece of matter that can exist independently. Yes, somebody will be telling me that there are subatomic particles, protons, neutrons, electrons, but they don't exist on their own. They exist as part of something bigger. Identical atoms, absolutely identical, are called an element. And 2 or more atoms joined together to make a molecule. This really is word version of the pictures we saw as our starter. So as I say, make some notes. Remember, you can pause while you do this. Now let's look at atomic structure. This is one square from your periodic table. It has two numbers, it has a capital letter, it has a name in small writing. This is the square for boron. The name of the element is given there in full, but in small. Also the symbol for it. This is one, sometimes two letters. The first letter is always a capital. So if you've got a formula, you can count the number of capital letters to know the number of elements inside the formula. It has an atomic number here, 5. This is the number of protons inside your atom. So if it's got an atomic number of 5, it has 5 protons. And because proton and electron numbers are always equal to make the element neutral charged, it means it will, if it's got 5 protons, it will have 5 electrons. The mass number down here is 10.811. That's because there are different forms of boron with slightly different weights. But to the nearest whole number, that would be 11. So that means the number of protons plus the number of neutrons in one atom will equal 11. Now we already know from our atomic number up here that there are 5 protons. So if there's 11 bits all together in the middle, there must be 6 neutrons. If you're not too sure about this, you can use your periodic table, choose a couple of elements, look at their proton number and their mass number and work out the number of protons, neutrons and electrons for each. If you put that in your notes, you can either send a photograph to me or you can write it in your notes in Teams and I can check it for you. I'm sure you'll be good at this, so we have done it before. Now electrons are in shells. Okay, that's what these little circles are, they're shells. They don't stay still like they do in this picture here. They move around really quickly, they orbit, but they stay as far away from each other as possible. They're a little bit antisocial. The inside shell always fills up first. There can be 1 or 2 electrons in that. When there are 2, then the next shell will start to fill up. There can be up to 8. And then you'll fill, then if that was full, you then get a third shell. When you look at your periodic table, the period, the bit going across, shows how many shells. Boron is in period 2, the second row, so it's got 1, 2 shells. There you go, 1, 2 shells. The group, which is up and down on your periodic table, shows how many electrons. Boron is in group 3, so it has 1, 2, 3 electrons in the outer shell. That's just how many are in the outer shell. So check again, 1, 2, 3. So group 2, sorry, period 2, so it's got 2 shells. Group 3, so it's got 1, 2, 3 electrons in the outer shell. Nice neat trick, that one. If you need to write the notes on period and group, then you need to pause. Moving on to word equations. I'm sure you're going to remember this. We came up to this before around about Halloween. In science, an equation shows changes during a chemical reaction. It's not exactly the same as a maths equation. It's the same word, slightly different context, so it's a slightly different meaning. Chemical reaction happens when atoms are rearranged and electrons are rearranged. The starting chemicals are called reactants because that's what have the bits that have the reaction. They're on the left. Just like an ordinary sentence, it goes from left to right. It's a chemistry sentence, but it still goes left to right. The ending chemicals are called products. They are what is made, what is produced, so they are the products. They're shown on the right. An arrow shows the direction of change, and slightly grim, RIP. The reactants go in front of the products. Bit cheesy, but it helps me remember it. And labelling reactants and products still can come up at GCSE, so this is definitely a key skill. So let's practice it. Now, here is a sentence about a reaction. During respiration, oxygen and glucose are changed into carbon dioxide and water inside the mitochondria. So it's telling you what the process is, respiration. It's telling you all the chemicals that are involved. I've underlined those because I'm feeling kind today, and it's telling you where it happens. The only bits you need to include for your reaction are your chemicals. Remember, RIP. Your reactants go in front of the products. You have an arrow to show the direction of change. You need to pause while you write your answer. Remember that pause. And you should have this. You should have oxygen plus glucose gives carbon dioxide plus water. Doesn't matter which order oxygen and glucose can be. It could be oxygen plus glucose, or it could be glucose plus oxygen. You've got an arrow to show the direction of change. These are your reactants. They are what you start with, the oxygen and the glucose. They make carbon dioxide plus water. Could say water plus carbon dioxide. And these are your products. So it doesn't matter which order these two are, as long as they are before the arrow. Doesn't matter which order these two are, as long as they are after the arrow. Remember, reactants in front of products. When you say in front, you use that reminder. Put your arrow in where it says in front. Now, tricky bit here, you're going to want to remember these rules. I suggest you write them down. So, when you are naming a chemical that's made from two elements, you need to ask yourself some questions. First of all, how many metals are involved? If there's no metals, the element that is on the left and the periodic table is written first in the name of the compound. If they're both in the same group, the one that is at, sorry about that, just realised I put my space in the wrong place, let's change that. The one that is the bottom of the group will go first. If there's only one metal, one non-metal, the metal will go first. Two metals, you use both names and you write the word alloy afterwards. An alloy, it's like alloy wheels, is two metals joined together in a compound. Second question, how does the second element's name change? Oxygen becomes oxide, sulfur becomes sulfide, chlorine becomes chloride. So if you have a look, the endings change. They all become IDE, 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 IDE. Tells you that something has changed in a reaction. You will know sodium chloride already, which is table salt. So you've got a spelling pattern there. You might want to write those down as well. If you do, remember you can pause. Part 3. Is there more than one atom? If there's only one, sometimes you put mono in to tell you there's one. Carbon monoxide is CO. If there are two, you put in a di. Di means two. For example, carbon dioxide, CO2. Look very similar. Neither's particularly good for you, but carbon monoxide is actually a deadly poison, whereas you can tolerate some carbon dioxide inside you. You know that because you make it in your body, but then you breathe it out. Now, if there are three atoms, tri is added. So far, so good. Easy peasy, lemon squeezy. I hear you saying. That's good, year 8, because that's exactly what I want you to be saying. Now, check-up time. Ha-ha. On the left, we have got two elements that take part in a reaction. 5 sets of them. On the right, we've got 1, 2, 3, 4, 5, 6, 7, 8 possible compounds made from them. Mean miss. There are more compounds than there are reactants. That means I've put some extras in to try and catch you out, but I'm hoping that I don't. So you need to remember the 3 rules you've looked at, and you need to remember the endings for the second element, and all you need to do, you need to copy this out, copy that column out, and do some lines to show which ones go together. And you should have 3 in this column that do not have a line. You will only have 5 lines. You will have 3 left out. you will need to pause the video while you do it. And here are your answers. So as you can see, chlorine and lithium. Lithium is the metal. Remember, it's one of our alkali metals that has a brilliant reaction in water. Makes lithium chloride. See the ending change from ene to ide because there's been a reaction. Then you have oxygen and iron. Iron is your metal, so that goes first. Iron, oxide. So oxygen becomes oxide. Third one, carbon and oxygen. Can't tell there's two of those, but we can recognise the elements, carbon and oxide. That tells you it's oxygen. Di tells us there's actually two of those oxygens there. Sulfur and potassium. Potassium is our metal on the left hand side. Potassium sulfide, changing to an ide because the reaction has happened. Nitrogen and aluminium. Aluminium is our metal. Nitrogen changes, it becomes nitride. Didn't have that on the list, but it follows the pattern. If you got them right, put your hand up, bend your elbow, give yourselves a pat on the back. If you didn't, go back and check those rules and make sure you got them down properly. Let's carry on. You're doing really well. Now, we have got some word equations where I've only given you the beginning. But I have been kind, I have put the metals first. So you've got copper plus sulfur, arrow. Remember, reactants in front of products, RIP, these are your reactants. That's your reminder that in front, you need to put your product over here. Iron and nitrogen, Chlorine and carbon, Calcium and fluorine, Nickel and oxygen, la la. Now, for all of these, you are going to need to write out the starter, the arrow, and the products. You cannot just do the products because you are writing a word equation. You need to have what you began with, show it changed, what you finish with. Again, you are going to need to pause the video here. Okay, I'm going to guess we did pretty well here. The only one where I was mean was chlorine and carbon. It's carbon chloride. It's not a metal, but it's a special case. Remember about that from when we did the reactivity series, I'm sure. If you got all 5 right, stand up and take a bow now. If you didn't, go back and check why. Remember, do your corrections in another colour so that they stand out and you remember them for next time. Okay, electron arrangements. You are going to need 2 hands for this. Luckily, I remember that you have all got them. If there is only 1 electron, it goes in the inside shell. If there are 2 electrons, they both go in the inside shell. This shell is full. I remember the inside shell has only 2 spaces for electrons by putting my thumbs up. Thumbs up for the inside shell. 1 or 2, no more. None of you have got more than 2 thumbs. That's how many go in the inside shell. Any other electrons will go in the other shells. Let's look at those now. We've used our thumbs. I wonder what's going to be next. Oh, thank goodness for that. It's fingers, not toes. No need to get smelly socks off. Other shells fill one at a time. These shells are larger because they're further away from the centre of the atom. Because of this, they can take 1, 2, 3, 4, 5, 6, 7, or 8 electrons. At 8 they are full and you need to start another shell. Fairly straightforward. Probably should have remembered, had that in the introduction. Do like to remember. So thumbs up for the inside shell, that's how many. Fingers for all the others, wiggle those and check. Bit of fun coming up now. This is a link to a simulation where you can practice building electrons. It's a really fun one. We have used it in class before, but it's always good for a bit of revision. While you do it, you may want to draw pictures of the elements you're making, the atoms you're making. Make a note of the number of protons, neutrons, electrons, the name of it. It shows up on the periodic table. Please do at least 5. You will need to pause the video to copy the link and go to it in your browser. electrons and reactions, we are very nearly there. Oh, we're more than halfway there. So I don't need to sing. That's a shame, isn't it, Year 8? Okay, chemical reactions, we've already said, occur when electrons move between different elements or different atoms. This is because the atoms want to fill an almost full shell. So if you've got 7 electrons in your outer shell, you want to have 8. You want it to be full up, it's neat, it's tidy, it doesn't look odd. Or if you've only got 1 or maybe 2 electrons in it, you want to get rid of it, empty it, so that actually the shell below it is completely full. The electrons that move are always those in the outermost shell, the one on the outside. Makes sense, they're not going to have to barge past any others, and those are the shells that will be either not completely full or close to being empty. So, 3 types of bonds, not James Bond. Sorry, we like him. Oh, bad science joke coming, I'm not going to make it, you can do it for me. So, if you have a metal and a non-metal, you make an ionic bond. Not ironic, ionic, no R there. Metals given electrons 1 or 2, the non-metals take them. That way, both elements end up with full outer shells. If you have 2 non-metals, you have something called a covalent bond. Weird word, just have to learn it, I'm afraid. Electrons are shared, so each of them shares nicely, just like happy brothers and sisters. If you have 2 metals, imaginatively named metallic bond. Easy one to remember, okay? The metals give electrons to each other. There's another type of, these move around, they're not shared, they're moving all over the place. Because they're not in one place, they are called delocalized. They're not in one local place, they're all over the place. The type of sharing, delocalized electrons. These delocalized electrons are what conduct electricity. You've probably heard of those before. We did that in Year 7. Right, you know, the big finish coming up now, Year 8. So, a little bit of the periodic table here to give you a reminder. Going across, we've got our groups. Going up and down, we've got our periods. So, if something is in 1, 2, the 3rd period, that means it will have 3 electron shells. If it is in the third group, sorry, getting tongue-tied there. 1st, 2nd, 3rd group will have 3 electron shells. If it's in the 4th period, like this, it will have 4 electrons in the outer shell, 5 electrons in the outer shell, 6 electrons in the outer shell, 7 electrons in the outer shell. Group 0 actually has a full outer shell. It doesn't want to lose anything. That's why it's 0. You have got 1, 2, 3, 4, 5 questions here that all need to be answered in full sentences. This is the end of your lesson. You will have lots of notes to share. You can either share them by having completed them on Teams, or you can send me a picture of them or email these 5 answers in particular to me. If you've got any questions, of course you can email me as well. You will have Seneca set separately from this. So you have got 2 tasks to do, Seneca and this tutorial. And next week we'll be moving on to something where we're actually making new learning. So make sure you know all of this, because you need to know it all for next week. Stay safe. Speak to you soon, Year 8. Goodbye.